Good morning, class. Good afternoon, all, and you are welcome to today's class. Last class, I think we talked about in a measure of location, measure of dispersion, and today we are talking about measure of dispersion. I think that's our study sections 2, Unit 3. What are the objectives of the study? The objective of this unit is to help students understand and apply statistical measures that describe the spread and variability of data. By the end of this unit, students will be able to 1. Understand the concept of dispersion and why is it essential for interpreting data beyond measure of central tendency, which is the measure of location. Secondly, the student will be able to learn the different measures of dispersion, which include the range, the mean, deviation, variance, standard deviation, and coefficient of variation. The third objective is to develop skills to compute this measure for both grouped and ungrouped data. Also, interpret the meaning of dispersion measure to evaluate consistency, reliability, and variability in real data sets. And the last but not the least is apply appropriate dispersion measures in disciplines such as engineering, physical sciences, and business to support decision making and analysis. Learning outcomes for study section 2, unit 3. By the end of this unit, students will be able to 1. Define the concept of dispersion and explain why it is important in descriptive statistics. 2. Identify and describe different measures of dispersion, which include the range, the semi-interquartile range, mean deviation, variance, standard deviation, and coefficient of variation. The third is to compute the mean, the range, standard deviation, variance, and coefficient of variation for both grouped and ungrouped data. Also, interpret the meaning of calculated dispersion measure in the context of real-world data. Differentiate between absolute and relative measures of dispersion and explain when it is appropriate to use each method. Analyze data sets to determine which measure of dispersion best describe the spread of the data, and also apply dispersion measures to practical scenarios in science, engineering, businesses, and research to evaluate consistency, variability, reliability, and reliability of data. Introduction. When we are talking about measure of dispersion, last week I think we talked about the measure of location in our study section 1, study section 2, unit 1. But today we want to talk about measure of dispersion. We want to talk about measure of dispersion. What do we mean by measure of dispersion? Every data consists of some variability within its range. That is, variability in data is defined as far apart the data lie from the center of the distribution. That is, how spread the data is from the center of the distribution. It is also known as the spread or dispersion of the data. Dispersion of data is defined as the degree to which the arithmetical data is approached to spread an average value. Dispersion of data is defined as the degree to which the arithmetical data is approached to spread an average value. A measure of dispersion helps in calculating the variability of the data, that is how spread the data is. It is essential for summarizing the characteristics of data and also helps in calculating the variability of data, in stating the facts and figures of the data. So the measure of dispersion, what are those tools that we use in measuring dispersion in statistics? The first one is the range. When we say the range, what is range? The range is the difference between the largest and smallest observation in a data. It is the simplest method of measuring dispersion, and it is commonly used in statistical quality control. That is one of the fields in statistics. However, the range may fail to discriminate if the distribution is of different types. Then from there we can calculate our coefficient of range using L minus S over L plus S. Then we have another tools that we use in statistics to measure. Another tools we use in statistics is also semi-interquantile range. These are the tools that we use in dispersion. Semi-interquantile range is half of the difference between the first, that is the lower, and the third quartile, that is the upper. It is a good measure of spread of a mid-range and the quantile. When we say the difference between the first quartile, the last time we talked about quartile, I told you that we have 25%, which is the first quartile, 50 is the median, second quartile, 75 is the third quartile, while 100 is the fourth quartile. So semi-interquartile range is the difference between the first lower, which is the 25th quartile, and the third quartile, which is the upper. It is a good measure of the spread of a mid-range and the quartile. So the formula for semi-interquartile range is Q3 minus Q1 all over 2. Then we have the mean or absolute deviation. You can call it the mean or absolute, the mean deviation or absolute deviation. When we say the mean deviation is also known as the mean absolute deviation from the center of a distribution. A measure of the center could be arithmetic mean or median. So given a set of numbers or data, the mean deviation from the arithmetic mean is defined as mean deviation summation I ranges from 1 to n xi minus x bar all over n. From here, our xi are each sample or data given. Last class, I think when we are talking about measure of location, I said our x bar, if you could remember that our x bar is summation of xi all over n, while our xi are those sample points given or the data given. We sum everything together and we count the number of observations given, which will give us our n. So that then last time when we are studying about measure of location, I think we talked about the grouped data and the ungrouped data. So in case of a group data, MD summation of xi minus x bar over n is for ungrouped data, while in a group data the mean or absolute deviation is given as summation of I ranges from 0 to 1, I ranges from 0 to n, f of xi minus x bar. If you remember last time when we are talking about group data, if you could remember, we talked about frequency, that is the number of times that data occur. So here also our f will be our frequency, our xi are the each sample point given, and our x bar is our summation of xi all over n all over summation of fi. So our fi is the frequency. We had all the frequency together. So example, below is the average of 6 sets of household randomly selected from a country of 47, 45, 60, 56, 41, and 54. They said we should find the range, the mean deviation from the mean, and the mean deviation from the median. The ranges will be the highest minus lowest, which is 60 minus 41. That one will give us 19. Then the mean, I told us last week when we are studying, last week in study section 2 unit 1, that the mean is summation I ranges from 1 to n xi all over n. Then we had each sample point together, that is 47 plus 45 plus 60 plus 56 plus 54, divided by the number of observation, which is 6. So that will be 47 plus 45 plus 60 plus 56 plus 41 plus 54 divided by 6. So that will give us 50.5. That is our x bar. Then we estimate the mean deviation of the absolute deviation, which is summation I ranges from 1 to n xi minus x bar all over n. That is each sample point minus our x bar, then we take the absolute deviation of it. The first one is 47 minus our x bar, which is 50.5, absolute value, plus 45 minus 50.5, absolute value, plus 60 minus 50.5, absolute value, plus 56 minus 60.5, absolute value, plus 41 minus 60.5, 50.5, we take the absolute value divided by our number of observation, which is 6. Then 47 minus 50.5 will give us minus 3.5, plus 45 minus 50.5, that will give us 5.5. Then we do for the rest and we divide it by our total number of observation. But one thing I want you to take note here is absolute value of any negative value or any negative figure will give us positive. That is, the absolute value of 3 minus 3.5 is what? 3.5, plus absolute value of minus 5.5 will give us 5.5. Absolute value of any positive number is that same number. So what changes there is when we are taking the absolute value of any figure, any negative figure, it will change to positive. That is, it will now be 3.5 plus 5.5 plus 5.5 plus 9.5 plus 3.5. We add everything together and divide it by 6. That one will give us 37 divided by 6, which is 6.17. Also, when we are calculating for the mean deviation from the median, I told us earlier that whenever we are dealing with median, we first of all have to arrange from the lowest to the highest. So in array, we have 41, 45, 47, 54, 56, and 60. So I told us last time that our median, we have median for odd and we have median for even. So here now our sample, the number of observation given here is 6, which 6 is an even number. So we use the formula for even, the median for even. So we have n over 2 plus x into bracket n over 2 plus 1. So here our n is 6. 6 divided by 2 is 3, plus 6 divided by 2 plus 1. That will be 3 plus 1. That will be 4. So we look, after arranging the figure from the lowest to the highest, now we now look for figure that falls in the third position. After arranging, the figure that falls in the third position is 47, plus the one that falls in the fourth position is 54. Therefore, we add our 47 plus 54 together, and so the median will now be 47 plus 54 divided by 2, which will give us 50.5. Then the mean deviation will now be 47 minus 50.5, which is our x bar, absolute value, plus 45 minus absolute value of 45 minus 50.5, plus absolute value of 56 minus 50.5, plus absolute value of 60 minus 50.5, plus absolute value of 41 minus 50.5, plus absolute value of 54 minus 50.5. So that will give us absolute value of minus 3.5, plus absolute value of minus 5.5, plus absolute value of 5.5, plus absolute value of 9.5, plus absolute value of minus 9.5, plus absolute value of 3.5. But note one thing, that absolute value of any negative figure is still the positive of that value. Like the absolute value of minus 3.5 is 3.5. Absolute value of minus 5.5 is 5.5, and absolute value of minus 9.5 is 9.5, and the absolute value of any positive number is still the same, it's still that same number. Just know that any the absolute value of any negative number will turn to the positive of that number. So from there, when you add everything together, it will give you 37. Then you divide it by n, which is 6. That will give us 6.17. If you compare this plus the one for the mean, you will observe that it's the same. So then the next one is standard deviation. The standard deviation is denoted by sigma, and for the population, the standard deviation is defined as the positive square root of the arithmetic mean of the square of the deviation of the given observation from the arithmetic mean. Given as a set of observation, then the standard deviation is given by sigma square root of summation I ranges from 1 to n xi minus x bar all square all over n. Note, in standard deviation, we can consider either the population or the sample. When we want to estimate the standard deviation, we can estimate when we are considering the standard deviation for the whole population, be it grouped or ungrouped data, and we can estimate the standard deviation for when we want to consider samples, or we take samples out of the population. No, they have different formula. For please, it's not inside this material, but please take note of the formula. So the standard deviation when we are considering the whole population, which is sigma, is given as summation I ranges from 1 to n xi minus mu all squared all over n square root of summation I ranges from I to n xi minus mu all square all over n. Our mu is still our x bar, but since we are considering the standard deviation for the whole population, we use mu. But when we are considering for sample, that was when we use x bar. It can also be 1 all over n summation I ranges from 1 to n xi squared minus, open a bracket, 1 all over n summation xi all square, everything inside the square root. Let me repeat it again. When we are considering the population, not sample, when we are considering the whole population and we want to estimate the standard deviation, we use the formula sigma, which is our standard deviation, to be square root first. Inside that square root, you write 1 over n summation I ranges from 1 to n xi square minus, you open another bracket, 1 over n summation xi, close that bracket, then square. Or you can use this formula, summation square root summation I ranges from 1 to n xi minus mu all we close the bracket, all square all over n, everything inside the square root, where our sigma is the population standard. Is the population standard deviation when we are considering the whole population. Our n is the number of data points in the population. Our xi is each individual value or each individual data point, and our mu is population mean, which we can estimate as x summation of xi all over n. So now for this, this is for sample, but inside the formula given here also is not correct. Please take note. When since we want to consider the one of sample, we are considering sample. The first formula I explained is that of when we want to consider the whole population. But in this courseware and this study, we are considering the sample. Now, if we want to look for the standard deviation when we are using sample, when we are considering sample, the formula is our x. It's supposed to be s. Since we are considering the sample, not sigma, it's supposed to be s. Then it will be our s equals to square root of 1. You can say instead of using this n, it will be n minus 1. Please take note of the formula very well. It should be n minus 1 since we are considering the sample. Since we are not considering the whole population, since we are considering sample, it should be n minus 1. Or our standard deviation can also be, please, the second formula is totally wrong. The right formula is summation 1 square root. First of all, open your square root. Our formula is open a square root, 1 over n minus 1, open a very big bracket, summation xi square. That means we square all the sample points one after the other, minus, open a small bracket, summation xi all square. That means we first of all sum all our xi, we square it all over n. Please let me repeat myself again. When we are considering sample, we can use sample instead of the whole population. Maybe from the whole population we pick samples. With this formula for standard deviation, you can use either the first formula is open a square root, 1 over n minus 1, summation, I ranges from 1 to n, open a bracket, xi minus x bar, then close the bracket, all square. Note that 1 over n minus 1 will be at the back of the summation. Or you can also use, if you can also use, open a square root, 1 over n minus 1, open a big bracket, summation xi square. That means all our xi, we square it and sum it together. You can do that in a table, minus summation xi, close it, we sum all our xi, then we square the sum of all our xi, then we divide it by n. Then we now divide the whole bracket that we opened by n minus 1. So if we have like 6 samples, it will be 6 minus 1, which will give us 5. I don't know if that is clear. So for group data, we have for grouped and for ungrouped data. The first formula is the one I explained earlier, are for ungrouped data. So for grouped data, if you follow, it will still be the same format. The difference is that our f, the frequency, will be at the top, and instead of using n, we use the summation of fi, that is the sum of the frequency. We use our frequency to multiply the upper side, and we use fi instead of using n. That is just the difference. The same thing applies to the second formula. Then please note, the same thing also applies to the second formula, and please note, it will be summation, when we are considering the sample, summation fi minus 1 when we are using the sample, and when we are considering the whole population, we are not subtracting anyone. When we are considering sample, we take away 1. So that is the difference between the sample when we want to consider the population, or we want to consider the whole population, or we want to consider sample from the population. So please take note of the error in the formula for sigma in the courseware. So now variance. The variance of the set of observation is defined as the square root of the standard deviation. Once we estimate our standard deviation and we take the square root, definitely we get our variance. We have coefficient of variation. Coefficient of variation is another statistical tool for measuring dispersion. It is the ratio of the standard deviation to the mean. It shows the extent of variability about the mean of the population, that is the spread, the extent at which is the distribution, how the distribution, how it's spread. So the higher the coefficient of variation, the greater the dispersion. It is obtained by dividing the standard deviation by the mean and multiplying it by 100. Symbolically, it is presented as sigma over x bar times 1. So example, distribution with smaller coefficient of variation is said to be better. Given the data 5, 6, 9, 10 and 12, they said we should compute the variance, the standard deviation and the coefficient of variation. So from here, the formula for sigma, since we are considering the whole population, please take note, the whole population, not sample. So it will be summation, square root of summation ranges from 1 to n, xi minus x bar all squared all over n. So here we do our x bar. We first estimate our x bar, which is 5 plus 6 plus 9 plus 10 plus 12 divided by 5. That will give us 8.4. Then we now use the formula for sigma, which is summation I ranges from 1 to n, xi minus x bar all squared all over n. So from here, now the each sample, that is 5.5 minus 8.4 all squared, plus 6 minus 8.4 squared, plus 9 minus 8.4 squared, and we do for the rest. Then after doing that, we get 33.2, square root of 33.2 divided by 5. That will give us square root of 6.6. That's our standard deviation, and our variance, when we take the square root of 6.6, it will give us 2.58. Then we look for the correlation coefficient of variation. The formula for coefficient of variation is sigma all over x bar. Sigma all over x bar. So our sigma is 2.58 divided by our x bar. What is our x bar? Our x bar is 8.4, not 6.64. Please take note. There is an error there. Our x bar is 8.4, not 6.64. Our x bar is 8.4, not 6.64. So another example, they said, given the following data, compute 1, the mean, standard deviation, and coefficient of variation. The first thing is, these are the data given with ages in years. We have from 50 to 54, the frequency is 1. 55 to 59, the frequency is 2. 60 to 64, the frequency is 10. 65 to 69, the frequency is 12. 70 to 74, the frequency is 18. 75 to 79, the frequency is 25. And 80 to 84, the frequency is 9. Fine. So these are the classes, which is 50 to 54, that is the years or the age. We look for the mid class, that is the upper class boundary plus the lower class boundary divided by 2. From there, our 50 plus 54, we divide it by 2, that will give us 52. 55 plus 59 divided by 2, that will give us 57. 60 plus 64 divided by 2, that will give us 62. 65 plus 69 divided by 2, that will give us 67, and we do for the rest. Our frequency is 1, 2, 10, 12, 18, which was given. Then our f of x will now be x, which is our mid class or midpoint, that is the upper class boundary plus the lower class boundary divided by 2. We now multiply it by our f. So 52 times 1 will give us 52. 57 times 2 will give us 114. 62 times 10 will give us 620. 67 times 12 will give us 804. Then we do for the rest. Now, we now use from our formula. Our formula is xi minus x bar. That is one part. Then the second part is f of x, square root of f of xi minus x bar all squared all over n. All over fi, since we are dealing with grouped data. Now, how do we estimate our x bar? Please record our x bar when we are dealing with location, study section 2, unit 1. Our x bar, to estimate our x bar, it will be summation fi xi. That means our summation here, fi xi divided by summation fi. Please let me repeat again. So from this example, our x bar, when we want to estimate our mean for group data, it will be summation fi xi all over summation fi. That is our x bar. Therefore, our x bar will now be summation fi xi, which is our fx, all over summation f, which is 5549 divided by 77. Let me repeat it again. 5549 divided by 77. So here our x bar is 72.0649. Then to estimate our xi minus x bar, now it will now be 72.06 minus 52. 72.06 minus 52. That will give us 20.06. That will give us minus 20.06. That is xi minus x bar. Our xi is 52 minus our x bar, which is 72.06. That will give us minus 20.06. Minus 20.06. Our xi minus x bar will give us minus 20.06 because our x bar is summation fx all over summation f. That is how we estimate our x bar. When we do for the second one, that will be 57 minus 72.06. That will give us minus 15.06. Minus 15.06. Then the third mid class, which is from 60 to 64, that will be 62 minus 72 10.06. That will give us minus 10.06. Then we do for others. Then we now the column for f of xi minus x bar all square. Since we've estimated the one of xi minus x bar, we now use our f to multiply. Well, we can create another column to square our fi xi. That will be 20.06 squared. That will give us 402.40. Then we create another column again to do the one of f of xi x bar squared. That means we now multiply our f times xi x bar squared. Let me repeat myself again. After estimating xi minus x bar, fine, whatever we get, our answer, we can create another column and label it xi minus x bar all square. That means all the values we got from our xi minus x bar, we square it, create another column for the square, we square it. Then f of xi minus x bar all square, we now use f to multiply the new column that we created, which is xi minus x bar all square. That will give us f of xi minus x bar all squared. Then we now look for our standard deviation, which is summation I ranges from 1 to n f of xi minus x bar all square all over summation f. We now add the column of our column of summation f of f into bracket xi minus x bar all squared all over summation f. So we find the square roots, which is 47, square root of 47.7231. When we look for the square roots, it will give us 6.9082. Then we calculate the coefficient of variation, which is sigma over x bar times 100%. Sigma over x bar times 100%. That will give us 9.917%. Thanks for listening.